Yeah. I just realized that when we eat crab, the excess shell is much more plenty than the thing that we eat.
Exactly. All of this will go to garbage anyway because we can't consume it. That's making me wondering how many tons of crab shells are there in our country because, Indonesian citizens love seafood, especially crabs.
I know, right?
Secara maritim, Indonesia memiliki potensi yang sangat besar untuk menghasilkan komoditas kepiting. Tercatat bahwa di wilayah Selat Malaka, estimasi potensi untuk komoditas ini mencapai angka 12.829 ton. Untuk perharinya, permintaan kepiting dari tangkapan atau budidaya bisa mencapai 1,5 hingga 2 ton. Dan masih banyak lagi wilayah perairan lainnya yang menghasilkan komoditas primadona biota laut ini. Sehingga tidak heran jika kepiting menjadi komoditas ekspor Indonesia ke mancanegara.
What's wrong?
I cannot find a clothes for tomorrow's event. I think I'll have to buy it from an online shop.
Another? Don't you have tons already?
Yeah, that's right. But I've already wear all of them. I think I need a new one.
Well, you don't need a new outfit for every single new event. Because the clothes that we bought before is mostly from the fast fashion industry. And the fast fashion industry doesn't use a sustainable textile coloring. Instead, they use cheap and toxic textile coloring which contain chromium.
Is that bad for the environment?
Of course! Here, let me explain.
Masalahnya, fast fashion ini membawa dampak yang jauh lebih buruk lagi. Soalnya, pembuatan pakaian tidak hanya tentang menenun benang ke kain dan merangkai kain menjadi sebuah baju, tapi juga termasuk proses pencucian, pewarnaan yang memerlukan bahan kimia serta menghasilkan sampah plastik. Data menunjukkan bahwa air bekas proses tersebut menyumbang 20% dari polusi global karena industri. Masih ingat banjir merah di Pekalongan pada 2021 silam? Ini merupakan bukti nyata pencemaran air karena pewarnaan pakaian.
Words may inspire, but action creates changes. Dear judges and young researchers, may us introduce ourselves. I'm Shayna.
And I'm Radya, and we are from
Kesatuan Bangsa Bilingual Boarding School Yogyakarta.
And we proudly present a solution from the aforementioned problem.
We have developed a method to prevent the destruction of river ecosystem
by the amount of excessive chromium from untreated textile wastewater.
And the solution is crash film.
Wait, what is crash film?
Crash film stands for crab shell filtration membrane. This membrane utilizes a chitosan powder derived from crab shell mixed with acetic acid as the solvent. Chitosan contains NH2 and OH- which are able to bind to toxic chromium inside textile wastewater. By passing the wastewater through the crash film, the membrane will absorb the chromium inside it, which will reduce the amount of chromium.
How to make the crash film membrane?
The main step of the procedure is making a chitosan solution. To make one, we need two ingredients. The first ingredient is chitosan powder derived from crab shell, and the second ingredient is acetic acid. The next step is we need to measure the masses of the chitosan powder. In this research, we use three different variations of masses. The first one is 1 grams of chitosan powder. The second one is 1.25, and the third one is 1.5 grams. After we measure the masses, we then mix it with 35 milliliters of acetic acid. And then we mix them together with magnetic stirrer at room temperature for an hour to make sure that the solution is homogeneous. After that, we pour the solution onto a petri dish. And then we put the petri dish onto the oven and let it dry for 24 hours at dry temperature. After that, we need to ensure that the membrane is completely dry. After we take it out of the oven, we move to the tricky part, which is taking it off with the tweezers. Now, in these steps, you need to be very, very careful because we don't want to break the membrane. So, after we pull the membrane out of the petri dish, we can then use it and test it and analyze it.
How to make the chromium wastewater sample?
Prepare 37.42 milligram of potassium chromate. Next, put it inside 100 ml volumetric flask and then dissolve it with aqueous. After that, add drops of nitric acid to preserve the solution for at least several days until the observations are complete. Because the chromium best kept in acidic condition, the amount of nitric acid will be adjusted to create pH 3 and pH 4 condition for the variation chromium wastewater sample.
Everyone, we will do the chromium wastewater samples pH test. The objective of this test is to determine the optimum pH of the chromium wastewater samples for the membrane absorption. First, we need to cut the membrane into smaller pieces. And then, we prepare 100 milligrams of the membrane to be put inside the 3 milliliters of syringe. To be continued, we need to prepare 25 milliliters burette, peristaltic pump, beakers, stative clamp, and of course, the chromium wastewater sample. Next, we set up the burette, the syringe, and the peristaltic pump in the stative clamp. And then, we prepare 10 milliliters of the chromium wastewater sample to be put inside the burette. Beforehand, make sure that the burette is in a closed system. After that, we turn on the peristaltic pump in the slowest speed to increase the contact time of the membrane and the wastewater. Then, we slowly open the burette and let the wastewater pass through the membrane. Then, repeat these steps 3 times in each sample using the same membrane. Now, we will do the cycle test. The cycle test method is similar to the pH test, but instead, it uses pH 4 sample that is rotated 3 times, 5 times, and 10 times on the peristaltic pump and burette setup. Next, we will conduct the flow rate test. The purpose of this test is to find out which speed at the peristaltic pump is best to support the membrane absorption. The method and the procedure is similar to the pH and cycle test. The only difference lies in the activations of the peristaltic pump at various speeds: slow, medium, and fast. With each variation,
After conducting various tests, the sample was put into atomic absorption spectroscopy to determine the amount of chromium that can be filtered through the crush film. From the atomic absorption spectroscopy analysis, we can conclude that in this chromium wastewater sample pH test result, the membrane able to absorb best when the chromium wastewater sample is at pH 4. From the cycle test, 10 cycle is the greatest to support the membrane absorption because the more time the wastewater passes through the membrane, there will be frequent contact between the crush film membrane and the wastewater, therefore result in more chromium absorption. And from the flow rate test, the slower the flow rate, there will be longer time of contact between the crush film membrane and the wastewater, which result in higher absorption percentage. Okay, let me tell you another conclusion. First, the main procedure of membrane production is the preparation of chitosan mixed with acetic acid and brine. Second, the mass variation that creates the most effective membrane is 1.25 grams of chitosan powder. And the last one is the membrane with the most effective composition can absorb chromium up to 77.4%.